Now we have something very exciting coming up. And as you know, the promotion of young scientists has always been a major concern of the prostep ivip Association. So naturally, despite the special circumstances this year, of course, we would like to honor our two winners of the year. And as representative of the member group 3, Professor Dr. Rainer Stark will do the honors of handing out the awards to our two winners. So I would like to now hand it over to him. Welcome back on stage, Rainer.
Thank you very much, Jasmine. This is the very special moment always in the prostep ivip conference and symposium because it's a pleasure and an honor for us as the association and the community to honor two persons on behalf of what they really have delivered. Now we have two categories. We will start with the first one, which is in the category of the Best Global Master Thesis in Prostep ivip Association. And basically it is Mr. Max Leimkühler who has done tremendous work with the title called Feasibility Analysis of Machine Learning of Unbalanced and Unlabeled Data in Production. Let's have a look to the award trailer first.
Eine wesentliche Herausforderung bei der Entwicklung von Machine Learning im Produktionsumfeld ist die Vorlage der produktionsspezifischen Daten. Mein Name ist Max Leimkühler, ich bin 27 Jahre alt und komme aus Osnabrück. Ziel meiner Masterarbeit war es, ein Framework zu entwickeln, das industrielle Nutzer dazu befähigt, Machine Learning-Applikationen für das Produktionsumfeld zu entwickeln und in Betrieb zu nehmen. Ganz konkret habe ich mich damit beschäftigt, im Rahmen einer Fallstudie den Fräsprozess zu optimieren. Dabei war die große Herausforderung, Messdaten zu identifizieren, die den Fräsprozess in einer Granularität abbilden, dass ich daraus auch Erkenntnisse ableiten kann. Auf Basis der Messdaten konnte ich Machine Learning Modelle entwickeln, die es ermöglicht haben, die restliche Standzeit eines Werkzeuges beim Fräsen zu prognostizieren.
Die Ergebnisse von Herrn Leimkühler können vielfältig in der Industrie eingesetzt werden, weltweit, um dort die Produktionsprozesse zu verbessern. Wir an der Hochschule Osnabrück freuen uns, dass Herr Leimkühler den Preis gewonnen hat. Und wir hoffen, dass er in seiner wissenschaftlichen Karriere noch viele Schritte unternehmen kann.
Der Scientific Award hat mich dazu ermutigt und auch in meiner Entscheidung bekräftigt, mein Promotionsvorhaben weiter durchzuführen und meine wissenschaftliche Karriere voranzutreiben.
And now we have it on stage. Max, thanks a lot. And I think it was a great video and award trailer. So my honor on behalf of the association, the community, to your great work. And we hope that your future career will go along as planned. So what we have for you is, I'm not allowed to touch it. It's basically a little bit of a check here for you. But most important, the scientific award as a nice paper here, and I think you have done tremendous work on using bending moments in the tool holder to really find out what's happening at the tool when you do a body shell element milling. So that's a great work. We appreciate that again. So we wish you all the best for the future.
Thank you very much.
Very good. So a little bit of applause here. Yes, he deserved it. So with that, obviously, we have a second category, which is the winner of the best PhD thesis in the global world of prostep ivip Association. And with that, I would like to, first of all, introduce this work. It's called Hybrid Prototype in the Loop for Early ADAS Controllability Testing by Dr. Christian Buchholz. So let's have a look to the trailer first.
The main issues in today's industry are too late and too expensive testing with test cars. And I solved this. My name is Christian Buchholz. I'm 38 years old. I'm from Berlin. And I did my PhD thesis with the topic Hybrid Prototype in the Loop for Early ADAS Controllability Testing. I took the earliest prototyping from development and combined them to a totally new type of hybrid prototype.
Well, it was a challenge, first of all, from technology point of view, to combine visual environment, tactile instrumentation, and all the digital models, and to bring it into a framework and do real solutions with human beings in a real moving platform to simulate real driving, that was an absolute stunning element of his research.
Receiving the prostep ivip award was quite surprising for me, and I totally had a lot of fun. Hey industry, if you want to test your ADAS 1 year earlier, let's get in touch.
All right, let's welcome Christian on stage here. A little bit of a hand here in the room. Very good. So let me give a little bit of an insight. Obviously, when a professor turns in an award proposal, this person is not allowed to be on the jury. So I was not on the jury, but it was chosen as the best one. So Mark, congratulations to you.
Thanks a lot.
Christian, Dr. Buchholz, I think excellent work. I know a lot what you have done. So maybe tell us a little bit, what was your biggest challenge when you were doing this research?
Bringing all the pieces together, doing this excessive testing, this excessive work in preparing the drive simulator. So it was really, really a big technical setup I had to manage. And yeah, writing it all down, which takes like 1 year. So yeah, let's summarize it. Everything was challenging.
Now, great achievement. We talked about a lot of model-based systems. English is a verification environment. So since we know each other well, maybe my last question to you, I might be allowed to really ask this question. What are you doing with the money, actually? Because I forgot to say 1,000 euro for the best master thesis, you will receive 4,000. So what are your plans?
No plans anymore. I already donated it. So to UNO Refugees Help and to Medico International, two organizations that support refugees. So I already donated the full 4,000 euros, so I'm happy to get my money now. Yeah.
Very good. So that's excellent. So we fully appreciate that. So with that, I think honor again. It was a pleasure. And let's make an announcement. We will basically start next month to really set out the proposals and applications form for the prostep ivip Awards for 2021. So the global community, please stay connected and turn in your best work, because we need technical solutions and talents to really move into the future. Thank you. And just mind, I give the word back to you.
Congratulations. Now, Christian, you're going to have to put that, should we swap places?
Sure,
you can
sure.
go over there. You're going to have to put that down for just a minute, because we now look forward to even more detail on your project. And congratulations once more. Are you excited?
Thanks a lot. Yeah, totally.
Okay, because you spent all the money, right?
I already spent all the money, but
important detail.
Yeah,
but it's here. It's coming back into the bank. So, Christian, congratulations, and ladies and gentlemen, this is Christian Buchholz, and we now look forward to his presentation, Hybrid Prototype in the Loop for Early ADAS Controllability Testing. And please do not forget to type in your questions into our chat field if you would like to ask Christian something. There will be a Q&A session at the end of your presentation. Christian,
Thanks a lot.
The stage is yours.
Thanks a lot. Yeah, so in the following minutes, I would like to present you the results of my thesis. First of all, let's have a word on myself. As the video already told you, I'm 38 years old. I'm automotive engineering from education. I was, as you can see in my CV, I was active in other industries before I started my PhD thesis at the Chair of Industrial Information Technology from Professor Stark. What I will present you is the result of this work. Today I'm working at another company, Dassault Systems, and what I did there is to do a follow-up of my research. I'm working as a systems engineer to support companies in the field of systems engineering, to bring back also my academic knowledge in the field. So, regarding the presentation, let's first of all talk about the scope of the presentation to manage your expectations. So, what you see here, you see the green and the red field. So the green is what I want to talk about. The red, not here, not this place, but feel free to ask and to contact me whenever you like. So what I would like you to understand is, first of all, what is the problem I want to solve? Secondly, what's my solution approach? There's a special point on my solution approach, the drive simulator, which I will tell you a little bit more about it. And then at the end, I want to talk about what advantage would an industry have applying this approach. So what I won't tell you about it's, yeah, what's the scientific approach? You can have my PhD thesis later on if you like. You can see a lot about scientific there. And tools and methods for integration and test that I also developed. I put it a little bit out of the scope for this presentation. So let's go back to the title to introduce you. What I already mentioned, the hybrid prototype in the loop is the name of the solution approach. There's another point, the ADAS, which is most likely familiar for all of you, but if not, it's an abbreviation for Advanced Driver Assistance Systems. So systems that support the driver in his driving tasks, that may control the vehicle in order to avoid accidents and to interact with the driver by displays, by control elements. This directly leads to the problem, because what we see here is we see a lot of new technologies arising, and these technologies at least have the potential to change the interaction between the driver and the ADAS in the future. So let's took some examples from the pictures I chose. First of all is new digital control technologies and digital display technologies like big screens everywhere in the car, like touch surfaces everywhere in the car. We see, of course, the big trend of autonomous driving. For me, it's more about the interaction between the driver and the car. So it's about the semi-autonomous driving, where the driver still has a significant role in the driving task. And last but not least, electromobility, electrification. So what changes in the interaction between the driver and the car when we're talking about electrical car? And there are a lot of changes. This interaction between the driver and the car is heavily connected with an issue from the functional safety development. It's called controllability, which you also see in my title. Let's say controllability can be summarized by these three pillars. So basically, it's about perception of a situation by the driver, the decision for a countermeasure, and the performance of the countermeasure. So this can be done by the driver alone, by a non-autonomous car, or this can be done with the support of a ADAS or a mechatronic system, which is symbolized by the small robot you see on the picture, which can detect the environment by sensors, then perhaps inform the driver, okay, there is something occurring by a display, and at the end also change the behavior of the car by braking or by steering the car. This has an impact on the second stage, the decision for countermeasure, because in the future, the driver always have to take into account the reaction of the system to its countermeasures. So he cannot only think about the countermeasure himself, he has always to take into account the countermeasure of the system. And furthermore, there is always a control element. It's from a regulations point of view. The driver has always to be in control of the whole task and the whole drive. So always have to have the ability to override the system and to get control back at the end. So this is a control element is for. How is this controllability tested today? That's the big question. Basically, what you have to understand first is how it is developed. You see on the very left of the picture, you see these two development processes. On the one hand, the upper one is the development of the sensors, of the actors, of the control unit. Let's call it a mechatronic system. And on the lower hand, you see the development of the displays and the control elements. And today, automotive industry develops them quite a long time in parallel before integrating it the first time to a system prototype. Within the thesis, I did some interviews with car manufacturers to give you an idea. This integration, the first time this integration took place for the car manufacturer we interviewed is 12 months before start of production, which is obviously quite late, taking into account if we have a 4 years development cycle. So just after 3 years of development, it's the first time that you really can assess controllability by test. For sure, today you can take a look at it with an expert view. You can check it, you can review it. But if you think about how these systems will change and how the complexity will increase, you have to test it anyway. So the basic idea from my thesis comes from this point of view. So the basic idea is to get a front-loaded test. So the idea is to enable the earliest integrated test as possible. For this, I use the earliest executable models from development. So I took development prototypes that are already existing, integrate them to a new type of prototype. This is the name-giving hybrid prototype, and test them in a mainly virtual environment, which is provided by a drive simulation. Just a quick back look, why hybrid? Hybrid is just a prototype that has as many virtual elements as possible, but for sure, if I want to have a touch screen, if I want to have some control button, I still need some physical stuff. That's the basic idea. Make it as less tactile as possible, as much virtual element as possible. Taking a look to the setup I use there. First of all, you see the left side, which is mainly about the system environment. The system environment, for sure, what I already mentioned, is the real driver, which could be either an expert from development or also a naive tester, which have no contact to development whatsoever, and the drive simulator. The drive simulator is for providing the cockpit, so something that the driver can interact with, and for sure the virtual environment, virtual car and whatever. And on the other hand, we see the hybrid ADS prototype, which is based mainly on these three pillars. So virtual reality. Virtual reality is quite good way to make the driver to understand virtual displays, visual displays especially. Secondly, rapid prototyping for all the rest of the displays, for the haptic interfaces. So you need something at this stage in development to build prototypes very quick and to provide it to the driver very quick. And last but not least is the usage of software models. Usually in development, this is MATLAB Simulink, but could be also something else. Could be, for example, an executable SysML model. It's basically to integrate the system behavior into this prototype. And these both are tested in a loop. And that's the name-giving interaction loop. That's why hybrid prototype in the loop test, the loop between the prototype and its environment. So we did a lot of tests, as I already mentioned before, by answering Professor Stark. These tests were processed by both, both experts from development as well as naive test drivers. And let's summarize the main conclusions out of these tests. First of all, the hybrid prototype test approach is generally suitable and appropriate for this controllability assessment. The driver understands the test and also understands the prototype. And basically, and that was the target, we can assess earlier than today, or take it the other way around. When we take a look to the sub-prototypes we built this ADS prototype of, we can do much broader tests than with a normal software model test, and we can do the tests in much higher quality. Further finding was about the drive simulator. The drive simulator, as I mentioned at the beginning, is a key element. And it's a key to find the right drive simulator in order to run the tests. That's why main development within the thesis was a method to find out what's the right drive simulator. And basically it can be summarized to these three steps. So first of all, to provision of a to-be setup, which respects the use cases. Secondly, the provision of technical specifications, taking into account the today's simulator technology, and last but not least, the methods and tools to use this, respectively, to get test results. Using an example, a quick one, a visualization system, for example, this could be the field of view or the resolution of the system, which can be directly connected to technical specification, as for example from a head-mounted display. And for this kind of tests, an eye tracking is quite useful in order to follow the driver's eye looking to the display. So getting a summary under the evaluation could be, on the one hand, this what is seen on the right side, what I just mentioned. So first of all, we first time have a method to evaluate and to design the right drive simulator. That's a key finding, and it's not only useful for this specific use case, but it's also useful for other use cases. So you cannot only test controllability, but also ADAS functions or new interfaces whatsoever. Second main finding is described by the other two pictures on the left and the middle. It's you can, with using the hybrid prototype and the loop test approach, you can do a broad controllability test. And this test can be done 12 to 18 months earlier than today's controllability assessment with cars. But there is the word broad inside. You see, it's not a full test, because as you can imagine, when you use software models, you cannot test regarding the software safety. For this, you need code. Or if you integrate a display in a drive simulator, you won't see if there is, for example, some visibility issues or some reflections when it's installed in the right car. Still, you can test a broad range of controllability. And that leads to my final slide and the recommendation I can give you out of my thesis. The usage of this test approach in combination with today's test approaches. So what you can do using the hybrid prototype and the loop test approach is you can test up to 30 months before start of production, which could lead to a significant reduction of these test car tests. Secondly, you can test these new forms of driver ADAS interaction, and this quite early. And last but not least, you can sit everyone inside, also your manager that have no idea about the product itself. So you can ask him, okay, can you evaluate? Can you give your opinion on this? And so you can take decisions based on very, very early prototypes. That's it from my side. Thanks for listening. And yeah, I'm open for questions.
All right, thank you so much, Christian. Another round of applause for you.
You're welcome.
Sorry for being a bit late. Now, first of all, don't forget that when you leave stage in just a minute. And we have received a couple of questions, ladies and gentlemen.
All right.
Let's have a look at those. One of them I think you already answered. How long did it take you to complete your project? And how long did it take to build up your hybrid prototype? How many students were involved? That one you have not yet answered. That might be interesting.
It was a long process over multiple years. I was like 15 students to whatever mode. I think one of those may have maybe one of the students. So there were like master theses, project work, bachelor thesis, whatever. So really a lot of students participated in especially helping me to build the whole things and also to test the whole thing.
So how many years are we talking about in average or approximately?
How many years? Oh God, don't ask this question.
I think it would be interesting.
Yeah.
If you can say so.
I finalized right now. I started in 2012, so at the end, 8 years.
All right. Okay.
All in all, but yeah, was worth it and was a lot of fun working with Drive Simulator. Who can do this?
And the initial spark, the initial idea or inspiration was actually in 2012?
No, much later. In 2012, I had an idea, okay, I want to do something with the Drive Simulator, and then like perhaps in 2016, there was the more specific idea testing ADAS in an early controllability test.
I see, all right.
Yeah.
Thank you, Christian. Why don't we have a look at our second question, ladies and gentlemen? We had one more, and we always take them from the top. Here we go. What role did colleagues play in your PhD work? That happens to be from Mike Auricht.
Yeah, especially this colleague was quite helpful for me.
I think he wants some recognition right here on stage.
Obviously, we were sitting in the same room, so he was one of my main colleagues to talk to. But for sure, there were a lot of other colleagues, and talking with the colleagues was most important, especially because we are all in the same situation. We were all working in the same research institute on the same problem, so it's the most important to talk with them and to have a regular exchange.
Common sense. All right.
Yep.
Christian, can I ask you one last question? We do have a couple minutes. What
I
comes?
think so,
yeah, right. What comes next? What is your next project, or is it too early to ask?
Ooh, this depends on my employer. So I'm actually working at Dassault Systems, as I mentioned. So I have already a lot involved in a lot of projects. And personally, I'd like to try to have follow-ups on this topic because I find it quite interesting and try to find ways to bring this together with my daily work and also let my employer benefit from this kind of things, because I think also the Dassault system doesn't have this in place. So let's find a beneficial work mode for both of us.
I think your employer will be very happy and satisfied to hear that. Thank you so much. Congratulations
Thanks a lot.
Christian Buchholz. Thank you for
Thanks
joining us. And one more round of applause. I think we're good. We're good for that.